Okay, here we go. Wow, that's really loud. I'm going to turn that down a little bit. There. Okay, so we are talking about different forms of equations, and that very first one. Okay, some of you guys are still chatting. Stop. Thank you. Number one there, is that in factored form, or general form, or vertex form? General form. The good part about general form is it gives you the y-intercept right there, and it also gives you a and b and c if you ever want to use a quadratic formula on them. Okay, what is this form? That's vertex form, and the vertex in this case is negative 4, 1. Is that correct? No, because you use the opposite of what's inside here, so it's positive 4 or just 4 comma 1. Okay, this guy, what form is that? It's general form. One thing I notice on this one's got a negative out front. That parabola would be what? Upside down. It'd be flipped. An up-down flip because it's on the outside. All right, this one, what form's that? Factored form. How about that one? Vertex form. Okay, because this could be moved to the end, and then my point would be 2 comma 4. This one. Is it factored or vertex? It's factored. It's factored because factored means it's a big multiply problem. This times that. See, if factors are multiple things that multiply together, that's factored form. Okay, this one. General, it's only loopy about it is this h should be at the end, but it's still in general form. Okay, how about this one? Factored. How about that one? There you go. Y equals mx plus b. Nice work in the front row. Yeah, it is. That's right. Okay. And how about that very last one? No, it's not mx plus b. That only works on things that are linear. This is squared. Can you get the vertex from this one? You can get the vertex from this one. The vertex is at what? 0, 0. So we can call this vertex form. Is it factored? Because it's a big multiply problem. I can see where you're coming from, that the 2 and the x squared are sort of like factors. I think I would have had to give you credit for that. Even though it's not, it can't be factored any farther than it is, so I guess I could say it's factored form. And I could say it's vertex form because, again, you could say, if I stretched it out, 2x plus 0 squared plus 0, it's easier to see that it's got a vertex of 0, 0. So that last one's kind of really crazy. Okay, but you could also say it's a lot like this one, isn't it? Oh, use a black marker, that won't work real well. Isn't it kind of like this one, the last one? Just multiply it out, so it's sort of general form. If I had to pick out of all of those, I would say that it is in general form, because if it was written like this, then I'd have been for sure able to say it was vertex form, but I would have probably had to accept multiple answers on that one. All right, moving on. This is just plain old first, outside, inside, last. Just a 2-second reminder on that. First, x squared, outside, inside, plus 7x, last, plus 12. You got to be able to do that because factoring is the opposite of that. When you're doing factoring, you end up doing first, outside, inside, last a lot. And I just realized that this kind of looks like a frog. Okay, anyway. Converting general form to factored form. Basically, what multiplies to this becomes a really important question because you're always setting up these things and you're saying this number and this number have to multiply to that. All right. If I'm converting from general form to factored form, it looks generally like this, and generally they turn out to be factored with 2 sets of parentheses, but it doesn't have to be 2 sets of parentheses. It can just be like this. That's still in factored form. All right, moving on. If I'm going to put this in factored form, that just means factor it, okay? And you have to ask yourself, how many different ways can I make 18? A lot. I can go 2 times 9, except one of them needs to be negative, right? It could be either one. So then it could be 2 times negative 9. All right, and how else could I make one? 1 and 18. One of them needs to be negative, and then the other one needs to be negative. What else you got? 6 and 3, make the 3 negative and make the 6 negative. Any other ways to make it? I don't think so. You can always use fractions or decimals if you want to mess with somebody's head, but you don't actually do it in real life. We can't use like 36 and 1/2 to make the 18. All right. So they always, though, if you take all of these, they have a total. Like if I added up these two, when I multiply, I get this, but when I add, I'm supposed to get that. Which of these guys, these all both add up to 17 or, yeah, they both add up to 7. Wait. One's negative 17, one's positive 17. Thank you. These would add up to what? Positive 7. Ooh, so that's the ones I wanted right there. Okay. All right. So on these, let's say that I was going to pick where these should go, like this kind of thing. All right. Are they in the right spots right now?
The middle one, right?
All right. It was random chance. Now I could later on we'll know the probability of that happening. There were 3 different things that had to go in just the right spots. There was actually 6 different ways I could have arranged that. The order matters, and so there was a 1 in 6 chance that would happen since I just threw them up randomly. But the key things to look for, you go this times this to make this, and then you look at the outside and the inside to make that. And that's kind of the crucial stuff. Why don't we even talk about the firsts? Because the firsts are always going to be x squared. So it's all of these had to be right. Okay, anyway, let's do these real quick. So right off the bat, I know that the first answer has to come out to 8. I look at the 8 first. And then I look at these and I ask, are any of these going to actually multiply to 8? And all of them do. But only 2 of them multiply to positive 8. Top 2. So it's either this one or this one. And then I can say they have to add to positive 9. So it's got to be this one. So these 2 would add to negative 9. So that would be that one. And then that leaves these 2. Okay. This one, would this one work for this? I think it does. All right. The little flashy things that you see there? Okay, what that is an alignment thing. And like for instance, if I want to line up these red boxes all nicely with each other, I grab that one. I can't move it. Maybe it's because that's in the way or something. I'll try. Okay. I give up. That top one doesn't want to move. If I want to line this one up with that, see that it'll flash just for a second when I get it perfect. Oh, see that? That gray line? You can set that on your smartboard so that you can line things up perfectly with each other. And, oh, see how it lined up? The left edge of this one lines up with the left edge of that one. And if I go to just the right spot here, it will, okay, it's telling, there, all 3 left edges are lined up as good as they could be is what that little line means. Oh, that seems off to me, but anyway. Okay, so then here, these 2 line up nicely right there. Okay, so those are just the little alignment things that you can do under Format. Under View, Alignment right there. So if a teacher wanted to get those lined up, they can show guides for active objects. Snapping them too, if I do that, then when I get to the spot, it kind of like moves it over and like jerks it into position. You know what I'm saying? Instead of being smooth, it kind of snaps it in. So some people like it that way. Okay, moving on. I don't think we need to do too many more of these. I would look for things that multiply to 24, but all the green things multiply to 24. So the next step is I got to find things that multiply to positive 24. And this one multiplies to positive 24. And that one multiplies to positive 24. And of those 2, yep, that. Oh no. There we go. Okay. What? This is just awful. Okay, I give up. Okay, moving on. Convert the following from general to factored. That's just a plain old factor it problem. You make two sets of parentheses. You find two numbers. That multiply to 4 and add to 5, which would be what? 4 and 1. So I go 4 and 1. And this is x and x. And they're all the pluses in the problem. So a plus and plus. All right. Now, those are all pretty darn easy. So I'm going to move to a different, harder kind of factoring. Don't need to know about ingredients made with smiles and unbleached. Can they say that on Pepperidge Farm? That made with smiles? So they cut their face off and put it into the. That's disgusting. Okay. Anyway. Okay. Anyway. So this is just saying that if the last number is positive, like if I say x squared plus 2x plus 1, then my two sets of parentheses have to either be both pluses or both minuses, because this is only made by a positive and a positive multiplying together. Uh-oh. Crackly thing going on. Hold on. Fix my microphone. Okay, good. Or you can have a negative and a negative. Would also work to make a positive. All right. Let's get into some actually harder ones here. This is just multiplying it out. You do a lot of first, outside, inside, last. Ruggy. You need the tongue too. Like, woo! Anyway. That's the general two-factored form. Okay. So basically I gotta factor it. Well, let's see. 3 times 1 is 3. So this would make 3, or actually makes negative 3. So this could work here or here. Which one does it work on? Top one? Bottom one? This is showing how well you can FOIL, because if you can FOIL that in your head really quick, outside and inside, in this case, makes negative something, negative 5, it'd be that one. All right. That makes negative 6, positive 1, total of negative 5. Get that? All right. This one goes here. Okay. So main thing I got to check is my outside and my inside and make sure they actually make this. And they do. All right. This guy goes in the middle. Okay. Outside. Positive 2, negative 3 makes negative 1. Very good. And by process of elimination, that must be probably right, but I'm going to double check it. Outside, inside, negative 2, negative 5 makes negative 7. Okay, so if you were going to factor these, this is the first one I want you to actually do. In your notes, please. Write that one down. Factor it. We must be good at factoring. Seriously, top 10 skill for both this class and next year's class is factoring. You factor a lot. And when you have a hard problem to do, oftentimes it ends up coming down to, oh, if you just factor it, then things will cancel. That is like this common theme throughout this class and next year's class. Yep, do the starred one. So your first thought should be two sets of parentheses, and not just an x and an x, but a 2x and an x. Then you should be thinking, these two numbers have to multiply to negative 5, so one of them needs to be negative. So if I stick like negative 5 here and positive 1, and then just try it. Outside, inside. That makes a total of negative 3x. That's not what I wanted. So now I have to back up and try it in a different spot. Maybe it's minus 1 and plus 5. Positive 10, negative 1 makes positive 9. There we go. The firsts make 2x squared. The outside inside I already checked. And the lasts make negative 5. All right. So this one I want you to try. And it's got tough numbers. So whenever the numbers are tough like this, look for something to factor out of all of them to make them much easier. What comes out all these? 3 does. So then you got 3 and then 2x squared plus 7x plus 3, and then that will factor way easier. Go ahead and finish it. once you get that number out of there that makes all the numbers smaller, way easier. 2x and x, plus and a plus. All those things can just be figured out logically. Since there's only pluses in the problem, must be a plus and a plus. And it's got to be a 1 and a 3. The only question is if it's the 3 first and then the 1, or what, or vice versa. Check it. Outside, inside, makes a total of 3 for 5. It's not either way. That doesn't work. Must be the other way. Must be a 1 here and a 3 there. Outside, 5 and 1 makes 6. Wait a minute. It's supposed to add up to 7.
3 times 2.
Oh, 3 times 2 is 6. I thought it was 3 times 2 is 5 if it was in my feeble little mind. Okay. It's probably the Frankenberry talking. All right. What? This, do you see a person in there? It's got a hat on, and he's got a nose and a mouth. Is that what you're talking about? So we just need a couple of eyes in here? Okay. Anyway, more examples. Let's do one more. Factor that one. Factor that. All right. How does 5x and x strike you? Probably a good way to start. Next thing, got to multiply to 2. Ooh, that's a tough one. 1 times 2. The only question is, though, is it a 2 and a 1 or a 1 and a 2? And where's the negative? Okay, so then you just got to play around with it until you find it. I'm going to just randomly throw in plus 2 and minus 1, see what happens. I get negative 5 and positive 2 makes negative 3x. Here's a tip for you. If that ever happens and you get the exact opposite of what you wanted, all you got to do is switch the signs. Change it to a minus and a plus. Now the outside and the inside makes positive 5, negative 2 makes positive 3, just what I wanted. So if you ever get exactly the opposite of what you wanted on the inside, flip the signs around. Okay, raise your hand if you feel confident on factoring. You're good at this. Okay, good. If you're not, I'll give you more time later. We do not need to try more. I think we just need to get you some time to work on your worksheet. So here we go. Here we go.